Hello everyone. For this week, I'm sorry for not making a video for so long. I had midterms and I will catch up to all the modules. So let's get started. I'm gonna be talking about data visualization in this one. Now, I'm going to be using R for this because I'm only be going to be explaining concepts. Code, you guys can do it by yourself. All right. So let's see. Let's hear about bar plots. What are bar plots really? So what can bar plots be? They can be something like this, vertical, something like this, or they can be something like this, horizontal. Alright? Now, let's see one. On the x-axis, we have, for a vertical bar plot, we have categories, rural, suburban, unclassified, urban. These are categories. And on the frequency, on the y-axis, we have a numeric value. So this represents one numeric value and one categorical value. All right, this is the always, that's how you do bar charts. Now, there is these kinds of bar charts. So as you can see, inside of each categories, there are different categories as well. Now, if you go down, there is another type of bar charts called a stack bar chart. Now, if you can see, inside of one bar chart, it divides that one bar chart into its individual how many times and another factor, another category occurs inside of that one bar chart or one category. So this is some bar chart. Now these are some of the mistakes that you need to avoid. Do not get fancy. People sometimes add features to graphs that don't help convey their information. Like if you can see here, the first one is none, this is Windows, this is Macintosh. It doesn't really make sense if you make the 3D. Does this mean size? It is not as effective. Sometimes not all graphs are effective. You need to be able to figure out what kind of graphs is effective. Is this good? Macintosh, if you make a picture instead of that, does that look good? It really does not. So that is all about bar charts. Let's move on to pie charts. Kind of similar to bar charts, but they show it like this. They have a circle, and the area of each of these one will be how many, the percentage of the occurrence of each category. So one pie chart will only help you figure out one category in general. All right. So this is like a simple one: forest, horse, air, water. Visualizing. You can also visualize it by percentage. Now, which one would you choose, pie chart or bar chart? The main advantage of using a pie chart is it's quickly easier way to convey messages. So it does look it's easier to view, but normally they have no option to visualize two categorical variables. Can you say this? So that's why bar chart over pie chart forever. All right, next one, histograms and dot plots. Histograms. Now, so far we were dealing with one categorical variable, but what if both of our in both axes were quantitative variables like this? Both were quantitative, both were numbers. So in that case, we make a histogram. If you have taken stats 205 to 50, you see that histogram. You are familiar with this. If you are not, you would have to take stats because it will be a requirement for the next class. So you will learn more about histograms in that class as well. But it's a good thing to just understand the concept right now. Now, histograms can be of two types. As you can see on the frequency, they have like 0, 5, 10, 15, 20, 25, 30, or you can make it relative, with the highest one being 1 and 0 0.5, 0 0.4, 0 0.3. So that is easier to understand the ratio. Alright, this is why histograms are used for. Now, how do you describe a histogram? You say the shape of the histogram. Is it symmetric? Is it skewed? Are there any outliers? Is it unimodal, bimodal, or multimodal? What is the mean? What is the median? What is the mode? What is the spread? What is the variance? What is the standard deviation? Are there any outliers? That's it. That's how you describe a histogram. Now, there is another thing called as density curve. It is basically, it helps us see the patterns and trends more easily than a distribution curve like the frequency histogram. Now you can also, like we did the group bar charts, you can also make group histograms, and you could also make a separate plot for each of the categories. Very useful if you're doing machine learning. Now there are dot plots, kind of like histograms, but they plot each point as a dot. This kind of similar to histograms as well. All right, see, it looks kind of good. All right, so that is it about histograms and dot plots. Now there are more plots that we're going to talk about. This is the density plot and the frequency polygon. So now both axes is in fact uh, quantitative or numbers. So if you can see here, it just shows you, what does it show you? It shows you kind of like the histogram, but in a different way. It shows you the probability density function, which is like, what is the graph of this function? It kind of shows you like that. All right, you can also do it for different ones. Frequency polygon is kind of similar, but it helps you understand the shape of the distribution. You would normally, these go together, you would not use one or the other, but this goes kind of smoothly. This has like bumps and stuff. See, bumps, 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 bumps. So that's the difference between density plot and a frequency polygon. The next one that we're going to talk about are box plots and violin plots. Mm, Five number summary is something that you need to understand. Five number summary. How do you find what is a quartile? What is an IQR? It's yours up to figure that out. Now, from that one, if you look more, look at this. This is how you describe a box plot. So this point over here is an outlier. This is the third quartile. This is the first quartile. This is the medium. This is the minimum. This is the maximum value. Anything outside of this minimum and maximum is considered an outlier. I mean the minimum and maximum whisker values. That these are called whiskers. As you can see, whiskers. They capture roughly 99%, but anything outside of this 99%, that's an outlier. All right. Moving down, you will be doing everything like this in Python using Matplotlib. I'm not going to be doing that for this lecture because this I'm just going to be going over theory. If you want to do more towards coding side, you can. There are tons of resources online. You can look at that. All right. Violin plots, now box plots would look like this, like we talked about. Violin plots are similar, but instead of getting each point the five number summary, they get the distribution. That is the difference. Now you can combine box plot to a violin plot and get a good distribution like this. If you have a graph like this is the best one that you can use to describe it. Alright, that is it for this one. Now, so far we're dealing with just two variables, one on the x-axis and one on the y-axis. But what we have more, that is called a multivariate data. In that case, we will be building something like a coefficient correlation. I'm sorry, a correlation coefficient matrix. So as you can see, cells and newspaper, they are rated 0.2 to each other. I'm sorry, cells and newspaper, they are rated 0. Cells and radio, they are rated 0.6. Cells and TV, they are rated 0.8. Newspaper and radio are rated 0.4. TV and radio, this is basically the relation between them. And this color you can see, if it's 1, it means it's positively rated. If it's -1, it's negatively rated. Negatively rated means if one increases, the other decreases, called inversely proportional in physics. Positive or 1 means directly proportional, or if one increases, the other also increases. Now you can have a bunch of scatter plot matrix like this. Scatter plot is just pointing each plot, each x and y against each other. And there is a thing called, you can get something like this as well, where you can even see the distribution, the correlation value, and the graph. So it's pretty good. Alright? Now, if you add colors to this, it looks pretty good, right? If you have a distribution, if you have a graph like this, you can basically explain, see if any variable is dependent of each other and stuff like that. Next, so more about scatter plots, I'm pretty sure, yes. So we already covered this. Now, if you have categorical data, as what you would do, look at this. This is a very good plot. It is visualizing two categorical plots together by their counts. So it's pretty good. This is called a circular plot, circular bar plot. There is also this thing called lollipop plot. Let's see it. Not that good, but it's kind of, you can go over this. So search lollipop plot and it should be good. Alright. There is also called a tree map, which basically, I'm pretty sure you guys have seen stuff like this in 2048 games. It's kind of like tree maps, right? It's like the highest area will have the highest one, the lowest area will have the lowest one. Kind of similar to this, there's called a waffle chart, but it's divided into each sections. Now this is more like 2048 game, I'm sorry. Alright, now there's one more called mosaic chart, which kind of shows you the relationship between, let's see, how many variables is this showing us the relationship of the overall health and the ever smoked tomato, and the comparison between these two categorical variables. If you wanted to do a test, you would do a chi-square test for these. Now it's doing for 3 now. 1, 2, 1 variable, 2 variable, and 3 variables. So it's comparing 3 different variables at once. Now, these alluvial diagrams are a helpful way to show the relationship between two or more categories. So see over here how much is one related to each other. If you like deep down and see this picture for a few while, you will understand without even having prior experience to these graphs that what do these means, because we are humans and we design stuff that in a way that we like. Now, module 2, categorical, and this is categorical and quantitative visualizations. Cleveland dot chart is pretty good, right? One categories, and this is like the average of total case. This is like total cases. So if there's like one value in the number and one value in the x-axis, then you do this. But if there's like multiple values in the x-axis and it's just one value, then in the y-axis, then you do the strip plots. As you can see, there's multiple values here. 1 1, it is Cleveland dot. 1 many is a strip plots. There's also something called mean plots, something like this. This shows the confidence intervals, I think. Yes, it does. So I think if you have an idea of these sort of plots, you can basically visualize data. Now, up to the coding part, your professor did give you an assignment for midterms. A lot of you did good on that, so congratulations on that. And the more you practice, the more you learn. And I think that's it for me for this week. Thank you.